I would like to describe a field in which little has been done, but in which an enormous amount can be done. This field is not quite the same as the others in that it will tell us little of fundamental physics, but it will tell us much about the strange phenomena that occur just below our perception. In contrast to the natural philosophers of the past, the scientists of this field delve into the recesses of nature and show how she works in her hiding places. Their quest is to understand and create the imperceptible. After all, there is plenty of room at the bottom.
Hello and welcome to the Materialism Podcast, an exploration of the past, present, and future of material science and engineering. My name is Taylor Sparks, and I'm an associate professor of material science and engineering at the University of Utah, living abroad in the UK for a sabbatical at the University of Liverpool for a year. Today's episode is a continuation of our mini-series that's sponsored by UK Research and Innovation, and more specifically, Innovate UK and the Transforming Foundational Industries Challenge. Now, this is a funding agency in the UK dedicated towards many things spanning art, science, medicine, tech, and even material science. And in this series of 5 episodes, we are covering a number of different topics related to material science and the idea of future technologies in foundational industries. So in today's episode, we'll be talking about the concept of a circular economy with emphasis on how that relates to construction materials. And so to talk about that, today we are joined by Asselia Katenbayeva of the Alliance of Sustainable Building Products and Eoin Bailey of Celsa Steel UK. Would you like to introduce yourselves?
Thank you very much for inviting me to this podcast. Really love your podcast. Okay. So my name is Asselia. I'm a research associate at the Alliance for Sustainable Building Products. I've completed a PhD degree on material traceability at Loughborough University. So this is a very unusual topic of research because most studies have been conducted in other sectors, and my PhD was exploring this very important topic of material traceability specifically to the construction. In my current role at ASBP, I run research on steel reuse and supply chain traceability for timber products.
Thanks, Asselia. How about you, Eoin?
So I'm Eoin Bailey. I'm the Innovation Manager for Celsa Steel UK. Celsa is a steel manufacturer but also produces steel by recycling scrap, and we produce about 1 million tons of products for the construction sector. I joined Celsa about 5 years ago. I'm a designer by background, by training. I used to design cars and aircraft interiors for about 15 years before I joined the steel industry. So it's a new shift for me over the last 5 years, developing knowledge and understanding of the processing of steel and ultimately those foundation industries that builds the rest of the economy, really.
So these are interesting backstories. I'm curious, what leads a person to study supply chain traceability, and what leads a product designer to start thinking about circular economy issues?
So when I started my PhD research, the topics of ethical sourcing of materials and modern slavery were very prominent in construction. And I found that's a very important piece of research because our decisions affect supply chains, and within the global economy, our purchasing decisions have tremendous impact on the environment and the planet. And within the recent years, lots of shift has been on circular economy and net zero, and there's a huge potential for material traceability to aid circular use of materials.
Okay, and Eoin?
I started life designing cars back in 99 or so. And as a designer, I was quite frustrated with the way we used to design things and design for manufacture, knowing a little bit about the environment and the impact we're having on the environment. And then in 2008, I was asked by one of my customers, I was designing speaker systems for BMW, and BMW asked me to do some analysis of recycled or recyclable materials in the manufacturing of a speaker. And at the time, I knew it was going to be a fairly short study because we didn't have the infrastructure. Society didn't have the infrastructure back then for utilizing those materials. So I did a KTP, a knowledge transfer partnership project, where I was the associate. And so I researched for 9 months the entire life cycle of a BMW speaker. And that study really flagged up a lot of areas where we have so many contradictions and unintended consequences of what we do and how we do it. And it made me realize that the design and manufacturing process is very much stuck in a concept of a linear economy. And it introduced me to new ways of thinking and doing by looking at eco-design and cradle-to-cradle philosophies and how we can do things better. And so ever since, I've changed my career path. I'll only work with organizations who are eager to do new things and to do things much better than the way we have been.
Yeah, there's been a real shift society-wide in interest in this, right? So my next question was going to be, why should people care about a circular economy in general? What's the pitch? I'm curious what your thoughts are on that. What's the main reason why you think people should care about this?
Well, for me, it's we've been delivering what we do as a society for several hundred years now in the context of a linear economy, and ultimately, it's that this is the reason why we are all facing climate change, why we are struggling with the global supply chains being so insecure, really, and we need to change. We need to do things a lot differently because the reason why, or the reason we are in this mess, is because of this linear economy, and we've been doing it a long time. It's been around for 300,000 years or so since we started picking up sticks and stones and trying to hunt and feed ourselves. And we haven't really changed the mindset. So we desperately need to do things differently and change our economy effect, which is the reason why our focus on selling stuff and extracting of the earth's raw materials is the reason why we're in this mess. So we need to drastically shift the economic structures of our society.
And Asselia, specific to the construction industry, what additional nuances are there?
Well, the steel industry contributes to 7% of global CO2 emissions, and this is really a lot, and half of all steel produced is used in construction sector. At the same time, the construction sector is very wasteful. Almost 50% of all waste generated in the UK is because of the demolition of buildings and infrastructure. So that's why it's very important for us to consider how we can reuse materials, how we can minimize the effect of our economy.
Okay, I think it's pretty easy to sell people that these are really valuable things to think about. The hard part is when it comes to implementation. So my next question is, what exactly are the barriers? Like, why don't we just, cradle to cradle everything? What's stopping you from knocking a building down and reusing every last nut and bolt and every bit of concrete? What's preventing us from doing that?
So the steel is widely recycled. It's very commonly recycled, and 96% of steel is recycled in the UK. Reuse provides lots of benefits. However, there are additional steps associated with reusing steel. When the building is demolished, very careful processes need to be applied in order to recover that steel from buildings. Because, for example, the piece of steel, it cannot be dropped just on the ground, because if it's bent, then it cannot be reused in future. Certain steels, if it was subject to fire, then dynamic loads cannot be reused. If this piece of steel was used in bridges, again, it cannot be reused in buildings. And then when steel pieces are recovered from buildings, they need to be tested, they need to be recertified, their properties confirmed, and there are several processes with the designing of buildings based on what is available at the moment. So lots of companies are now interested in reusing steel, and we have lots of current projects with reused steel. But the problem now is that we don't have enough reclaimed steel to reuse it. This sounds really good actually, because if the demand is here, supply will follow. So yeah, that's the main barrier, is we need to recover more steel from buildings, so then it is reusable in future. Another barrier from my perspective is the lack of material traceability. So if we have a piece of steel and we don't know where it's coming from, we don't know its grade, properties, we don't know whether it was subject to fire, dynamic loads, then it is difficult to design that building, it is difficult to get insurance. So having that material traceability and properties would facilitate the testing, the certification process, and the design of these buildings.
I don't disagree with anything that Celia has mentioned, other than the fact that when you talk about the amount of materials being recycled in the UK, that's actually a lot less than 96%. It's assumed that that scrap material, for example, from demolition is sent off to be recycled, which is true, but not in the UK. 80% of all materials, all scrap materials produced or sourced in the UK is exported from the UK. Only about 20%, even less than 20%, is actually recycled in the UK. So I think we could do a lot more to keep material resource in the UK for the recycling purposes. And this is where Celsa comes into play, because we have to battle on a global market to keep the material in the UK so that we can actually produce the steel that we produce. And it is a low carbon steel in comparison to virgin materials. So there's a lot we can do to transition towards the idea or the prospects that Asselia is talking about in terms of steel reuse. There's multiple ways that we can deliver a circular solution, but I think one of the key aspects of to help us transition that is a full understanding of what the reality is, what is actually happening. Because we assume that material is being recycled, but we also assume it's being recycled in the UK, which isn't necessarily the case. Until you can follow the full life cycle from source, which is the demolition or even assessing before demolition, and connecting with your supply chain, then these are all possible things to be able to implement and apply. But if we just make assumptions and we don't really follow the life cycle and follow that supply chain, we're again kind of repeating the mistakes of the past where we will have these unintended consequences. Plus, we're missing out on the opportunity to keep resources, valuable resources, circulating within the UK economy.
Yeah, that's actually a very important point with that Owen said that 80% of scrap generated in the UK is exported. It's because we don't have enough domestic capacity in the UK to recycle. And that's why reusing steel is so important for providing socioeconomic benefits in the UK.
Okay, so I've heard really three great new things for us to think about. First off, if we're going to be reusing things, we got to do a better job of tracking things, right? We have to know what that steel grade was. That's one thing. We have to be able to recertify things, which assumes that you're going to be able to do all the materials characterization to qualify materials, but now on existing components, not necessarily on the pucks, right? On the forged or cast materials. And then we need to make sure that it's happening in the UK. If we go back, we did a podcast episode back in 2019, which feels like forever ago, number 12 on the science of separation, where we talked about this. I think it certainly blew my mind when I started digging into this to realize that when I put my stuff in the bin for recycling, it doesn't actually get recycled in the US. Most of the time it was getting shipped. And then increasingly, it's not even getting recycled wherever we send it to. So sounds like you're facing similar challenges in the UK. That said, UKRI is all about transforming this. It's reimagining the space in ways that can be a totally new approach. So are there examples of where we've actually adopted a circular economy in construction that you'd like to talk about?
Within the Disrupt projects on steel reuse that was sponsored by Innovate UK, we looked at 11 case studies with steel reuse. And within the 9 of them, steel reuse was actually integrated in projects. And these are the real great examples. These are various construction projects. Some of them are large commercial developments, some of them are smaller housing projects where steel reuse was incorporated. And in 5 of them, steel reuse resulted in economic savings. So there are actual examples of projects where even 100% of design steel was coming from reclaimed sources.
Can I ask real quick, when you say that you're reusing steel from a building, are you actually taking the component and finding an application for that same component? Are you cutting, are you melting it, reforging it? What exactly do you mean by reusing it?
That's a good point, yes. So reuse avoids remelting. So remelting is high energy process. And because of that, because we don't remelt that piece of steel, we just take it out from the building and we essentially put in a new building. And that is reuse.
So is that got to be challenging because as we move towards more and more customization, which is another benefit, right? Because it allows you to use less components if you make a custom design for that building as opposed to some one size fits all approaches, then you start running into problems, I imagine, where the components don't fit anything but the building they came from. Is this not a challenge? Maybe this isn't an issue at all.
It is a challenge, but companies need to work around this process because, yes, when you design a building with reclaimed steel, you need to consider what kind of steel is available now on the market. And then it's a part of the design process. And now several companies have developed a tool to match what is available and what is required in the design. So then the design process is efficient.
Okay. Owen, you want to talk about examples that Celsa Steel is actually putting into practice?
Sure, this is a case of the language, make sure we get the right language and put it in the right context. For me, circularity means many things. And in terms of steel or any product, the most sustainable building is one that already exists. And I think if the first thing we could consider or should consider is whether a building needs to come down at all. And can you reuse the structure or utilize the structure in its current form and apply it in a slightly different way? Then we could look at, okay, well, can we disassemble? And when we disassemble, can we reuse some of those components that are coming from that? We can remanufacture, but ultimately, if none of that's possible, you can still recycle or reprocessing, in my view, are kind of one and the same. Unfortunately, we don't necessarily recycle very much. We downcycle quite a lot because we don't necessarily design for disassembly and segregation. We have to try and put a lot of effort into that segregation piece. But from a Celsa perspective, Celsa's been in operation in the UK for 20 years, and actually at a group level, been in operation for 55 years. And all of our production processes is based upon the utilization of electric arc furnace, which means you can recycle materials. And for over 50 years, they've been recycling around about between 5 and 10 million tons of steel every year. And in the UK, it's a million tons every year. And for 20 years, we've been putting a million tons of material back into the UK economy. So I think that's a strong case study in itself. It wasn't always seen as part of a circular economy, because the circular economy concept, at least in terms of how the Ellen MacArthur Foundation is talking about it, has only been around the last 5 years. But what we've been trying to do is, rather than reacting to the end of a linear economy, which is ultimately what we all do when we recycle something, and ultimately when we design or when we disassemble a building and hope that we can reuse, we're still reacting to the end of a linear economy. What we're trying to do is actually encourage and educate on what a circular economy might look like by engaging with the supply chain, by going and working with the construction developers, with large contractors, and offering the option that they can, if they have a need to disassemble or to demolish, then we can take that steel and recycle it back into the next generation of building. And these are all things that are now starting to take shape. And particularly when you start looking at how we quantify the impact and reducing that impact, particularly around scope 3 emissions. When we demolish a building, the materials are classed as waste and therefore a scope 3 emission. When we procure new materials for the new building, it's also classed as a scope 3 emission. Now, if you can facilitate or be a part of the facilitation of capturing those scope 3 emissions from demolition and converting them into a value at procurement stages, then overall you can start to reduce the scope 3 emissions of that project. And that's where we're at the moment. That's where we're trying to look at the idea of circular steel vouchers, which helps you to capture the value of that scrap material and reinitiate it back into a new build. So these are all kind of, the way I feel, positive ways to start to introduce the construction supply chain to the concept of circularity. I'm not disputing anything that Asselia has been mentioning and the good work that her project is doing, but there's things you can do to help you transition and to educate and to offer practical applications of circularity that can reduce your impact and reduce your costs. Now, obviously, steel produced using a blast furnace, which is the virgin materials, iron ore and coal, you're talking around about 2 tons of CO2 per ton of steel, which is quite a lot, which is the reason why the foundation industries on steel in particular is a high emitter of CO2. But when you recycle that material through electric arc furnace, currently in the UK, with the mix of renewables on the grid, you can produce a ton of steel with 429 kilograms of CO2 if you can use electric arc furnace steel production, which is our EPD at the moment. And obviously that drops significantly if you can start to reuse those components as you move forward. So there's things you can do to help you transition and reduce your impact while still implementing a circular economy.
I think that makes a lot of sense. A couple of things, like first off, I love that you said that from an environmental standpoint, the best building is the one that's already built. There was an article by Rowan Atkinson in The Garden where he was talking about vehicles, and some of the things he said were controversial. He's not a fan of electric vehicles, but one thing I think most people can agree on is that if you've got a vehicle, we need to ditch this mindset of it being disposable, in 10 years. Like these things with a little bit of TLC, a little proper care, can be extended a lot longer. And it sounds like the same with buildings themselves.
Just a quick anecdote in terms of vehicles and electric vehicles in particular. As I mentioned, I used to design vehicles and vehicle components over the years. And one of the things I discovered during my research of a BMW speaker system is that we were using magnets in our speakers and they were made from neodymium. And neodymium is a rare earth element. We were making lots of claims about what neodymium was doing for the functionality, performance, and the efficiency of our speaker, which relates to fuel efficiency of the overall car. When I found out where neodymium came from and the impact the sourcing and extraction of neodymium had, where you strip mine landscapes, you separate the mineral from the ore using acids, and then all those acids are dumped back in, and then we're importing it into the UK and from China or from Mongolia, not really accounting for the impacts in those countries. And then I found out that neodymium is a critical resource in electric vehicles and wind turbines, and a lot of the low carbon technologies that we have around us and are striving to deliver. We're not really quantifying the impacts that these technologies have on our planet. Even though we want zero emissions in use, we're not really understanding the impact. And if we continue to look for electric vehicles and convert everything to electric vehicles, then the impact on the planet is going to be exponentially more than it is right now.
Well, I absolutely agree with you. It's a very controversial topic. One of the things I point to is there's been review articles by academics who've looked at the CO2 impact of vehicles. And the problem is that when people with supply chain traceability degrees, like these life cycle people do it, is that there's a lot of uncertainty. There's no one, it's not like there's one set of numbers that they agree on that this is the amount of CO2 that comes from electric vehicles. There's a lot of uncertainty. And then the other thing that comes to mind is that as we're using these materials, think of mines, right? You're not going to start with the hardest to dig up minerals. And yet, as we now massively increase the amount of these resources that we're using, it means that we're going to be opening up new mines, and they're not going to be the nice mines from before. They're going to be harder to get minerals. So there's just a lot of uncertainty. We don't know exactly what the CO2 footprint will be for those if you don't yet know what the grade of that ore will be or how you extract it. There's just a lot of uncertainty. So I certainly tend to agree with you on that point.
I think just one last point on this idea of critical resources. The other thing we're not really understanding or fully appreciating is when we export in the UK perhaps 8 to 10 million tons of scrap every year. In amongst that scrap, which is it's seen as just a ferrous metal that we can perhaps or somebody else can recycle, but in amongst that is going to be our critical resources, because we're not designing for disassembly. We are shredding vehicles at the end of life. We are recycling some of the ferrous metals and converting it into construction products. But ultimately, we're getting rid of potentially a lot of really valuable resources that we haven't even realized we have yet. And so there's a lot more we can do.
Well, one thing that I haven't yet heard from you, is there an example that has been put into practice where we're actually doing this materials tracing, right? Are there materials passports? Do we have digital twins? Do we have examples where we can actually keep track of these materials components so that if a company wanted to reuse them, they know the backstory so they can get the insurance, they can do what they need to do to use them efficiently going forward? Or is this something that needs to be developed still?
There's a number of things. We already have a number of valuable tools and mechanisms to quantify our stock of resources, but we're not really utilizing them effectively. For example, we have the end of life vehicle directive. And once you're designing a product and delivering it to market, you have to register on a database all the materials that are in your product, all the bill of materials in your product and everything that goes into that. Now, that's been there for 20 years or so, but we're not utilizing that as a mechanism to understand the value of resources that are there, including scrap steel. So that's one thing. We have a lot of data already, we're just not utilizing. And with that, you have the basis of material passports, I would suggest. But we need to move things forward and do things differently. As far as I know, there's a number of material passports being developed. Again, when we start using digital twins, digital modeling in construction, and we have BIM, building information modeling, then we should already have the foundations of a material passport to be able to run it across the supply chain and run across the life cycle of a building. So I think there's a lot we already have. We just need to start utilizing it more effectively again.
So, Asselia, from the Alliance of Sustainable Building Products perspective, are these tools, is the data sufficient, or do we need more data? Is it then just a matter of societal uptake of this information and starting to incorporate it, or what's your perspective?
I think one of the biggest barriers now is actually collating all this data, bringing all together, and having some sort of database or platform where companies can store that data, not only within their companies, but very importantly, that companies along the supply chain can collaborate. Because the construction sector is so fragmented, is so complex, and the information exchange and supply chain collaborations are one of the very drawbacks for supply chain traceability and for circular economy. So I think with the development of technologies, and especially the cloud-based platforms, blockchain type of technologies, there's a huge potential to have that information preserved. The construction sector is so different from other sectors in a way that buildings are meant to last. They're there for 30 years, for 50 years, maybe for longer. So the question is, will that information still be there at the end of that life cycle? So I think, with the development of technologies, we have huge potential then to implement and preserve that information for reuse of materials. So we looked at various case studies where steel reuse actually happened, and it's happening now in London and all over the UK. And some of the very great examples is there's a building called Intopia Building in Cambridge, and on the rooftop top of that building, there's a steel structure to hold solar PV panels. And this steel structure is coming from a movie set. So in a way that these pieces of steel, they had previous life. They used to hold camera rails and were used in filming for Marvel movies. And now it's having a second life as a part of a building. Another project that is very exciting is the Brent Crosstown substation in London. I don't know if you're driving from London, if you're on the train from London to East Midlands, you might see it on the train. It's a very beautiful, colorful structure. And it's a fence, so it's a structural steel was used as a fence for the substation. And what is prominent about is that the pieces of steel are coming from oil and gas industry, and now they were designed as a public piece of art, and it's very colorful and just shows how we can preserve materials and how we can reuse them. And just one more example that I'm going to add is, reuse can happen not only within the large developments, but also within the small cases, within the small scale projects. So there's a project where a very typical house, and the house owner is an architect, and she was looking for low carbon solutions. So what she did, she sourced the pieces of steel from a stockholder, and within her house she has reclaimed steel incorporated. So it's a very small scale project, and that resulted into cost savings to the project, and the whole process went so smooth and so quick, and the owner was really happy. It's just an example of how reuse can happen at different scales.
The thread in my eyes that ties those three examples together is creativity, right? And this is not a skill that I think we teach enough to engineers. And I think we actually screen out a lot of artists or creative people that think like, I'm not an engineer. And yet we need exactly those type of people to come in and look at this problem where you have this finite resource that we need to reuse, but it requires a really imaginative, different way of thinking. So yeah, I love those examples. Owen, you have another one?
Yeah, on your creativity point, just very quickly, I think that there's a really interesting TED talk with Sir Ken Robinson, who talks about how education kills creativity. So to your point, really, we need to be a lot more creative. But also, I think we need to be very good at telling stories and telling the stories about where stuff came from, where it goes next, and making sure that people realize that when devices and products and components have second, third, fourth lives, that we understand what those lives are. We were able to tell the story of those. I've got not quite the same sort of example, but we were working with a construction company in South Wales who were demolishing an old cinema in Port Talbot called the Plaza Cinema. And when I had a conversation with them about could we capture any of the scrap material coming from that demolition, we did ask about reuse, and unfortunately that wasn't possible within the structures that they were taking down. But what we did was we converted the scrap steel coming from the demolition phase, recycled it through our electric arc furnace, rolled it into new steel, cut, bent, fabricated into products that were then delivered back to the same site, which became the structural steel for the foundations of the new building. So it's helping to close the loop, really, and telling the story of how valuable resources can be and should be.
Maybe let's jump forward in your imaginations. It's the year 2050. We've solved our circular economy for construction materials. What's it actually look like? Who's running this? Is this like a government entity? Is this the steel manufacturers? Is this decentralized? Is it like blockchain? Is everyone keeping their own record of where things come from? What's it look like?
I think it's a very important point, because during my PhD, that was one of the topics I explored. Who's gonna benefit from the information, because that information is value in itself. And the companies I interviewed, they suggested that a third party should step in. It could be the government, or it could be a non-partial organization that stores all that information for such a long time. And lots of questions around how we can ensure the safety, security of that information, so it's not altered, so it's still preserved and it's still complete. But the question of who's gonna own and who's gonna manage it's a very good question. I don't have answer for this.
How about you, Owen? It's the year 2050. How does Celsa steel look differently?
I think what's interesting here is that the one thing we need to be mindful of is when we talk about circular economy, it's the economy is the challenge. The economy which needs to shift from a linear to a circular, and therefore the economics, how we quantify circularity within that economic structure. those economic structures really is key and critical, because there's a number of solutions that we already have out there. And we spoke before we started the podcast, we started talking about technology, and I made the reference to a bowler hat with sleeves, as in there's no point developing technology solutions just for the sake of developing technology solutions. We need to understand the application of those solutions and how and where we apply them. And for me, the two critical areas where we need to change and develop for circular economy is, one is our culture away from linear, to have a society that understands and can appreciate circularity delivered within its society, and also the economics. Because if our economic model is continuing to quantify value in GDP on the basis of digging up raw materials and selling stuff, then we're never going to reach any sort of form of circularity, regardless of whether we have a technology to quantify and to keep track of materials and have passports and so on. And I think that needs to happen before we really understand and embrace the technology solutions that we need to back it up. In terms of design, in terms of intent, in terms of tools and mechanisms, we have everything we need. It's just the economics and the culture are the two elements that are stopping us from moving it forward. And I think if we can get past this point, and then ultimately when we start looking at circularity, we need to start considering how service and citizens become part of the equation. We design for service solutions, whether it be a building or whether it be a vehicle or a mobile phone or whatever the case may be. We need to start designing for that service and the economics then to be a part of that. And we need to move away from the idea of consumerism. And consumers, the only thing we should consume is food. We shouldn't be consuming materials or products. And so therefore, we should stop, again, the language piece, where we stop referring to ourselves as consumers. We are citizens that utilize resources, and we need to utilize resources a lot more effectively. So I think these are elements that are probably more apparent than the technology piece. Although the technology piece and the adoption of means of quantifying the materials of where we have and tracing those materials is important, but there's a lot more we need to do beforehand, before we reach this 2050 panacea where we have a true circular economy in place.
Okay. I think that's a good note to end on. Today's conversation has been fantastic, and this is the last of our 5 mini-series episodes, but I think it does a good job of tying things together, because here in this episode, we've talked about a lot of the things that have been recurring over the course of these episodes. For example, learning to be creative and imaginative, coming up with entirely new solutions, not being stuck in the dogma of the way that they've been done, but also recognizing that we can't just see things as consumable, that we have to find ways to do more with less and reuse every bit that we've got. And clearly that's not going to be possible by any one of these entities alone. We've talked with a lot of great companies participating in the series, but they all have to interact with their consumers, with their supply chain, with government entities. And this collaboration, if you obviously go back and listen to our first episode in the series, and you'll realize just how important and foundational that is to achieving the goals of this Transforming Foundation Industries Challenge. Innovate UK is the UK's innovation agency. As part of UKRI, they provide over £1 billion per year of government funding for UK organizations to create a better future for inspiring, involving, and investing in businesses developing life-changing innovations. They also support innovative companies to grow through Innovate UK Edge and connect innovators with new partners and funding opportunities through Innovate UK KTN. The Transforming Foundation Industries Challenge is a program funded through Innovate UK. They recognize that decarbonizing the UK's foundation industries is a non-negotiable step in reducing global warming, meeting the UK's net zero targets, and speeding our transition to a low-carbon economy. The Transforming Foundation Industries Challenge is providing funding and support to create a cleaner, more efficient, and more competitive sector that is fit for our future. If you're an innovative UK-based business, or you're looking to innovate in the UK, find out more by searching Transforming Foundation Industries.
The Materialism podcast is also sponsored by Materials Today. You can visit materialstoday.com to stay up to date on the latest happenings in the material science field and read some of the fantastic articles that they've published. You can also head over to elsevier.com to find out more about their journals, books, conferences, and related programs.
We would love it if you would leave us a review. 5 stars on iTunes, Spotify, Google Play, wherever you're listening to your podcast. That will help other people find the show, and that would be pretty rad, we think. Special shout out to the people who make the music for the show. That's Alphabot and Kolobyte. I know we've said this like 65 times now, but if you haven't checked them out, you should do it. They make cool stuff. We dig it. Anyways, that's it for today. We hope to see you on the next episode. See you, everybody.
The inventors of fire, electricity, magnetism, iron, lead, glass, silk, cotton, the makers of tools, the captors of lightning, the architect, the engineer, the musician, are all beneficiaries of the materials of this world, and are bound only by their imaginations in manipulating those materials.